Alrighty, welcome to Algebra 2. This video is for Unit 6, Problem Set 4. It's going to be a really long video, so let's go right in. Given are the functions fx equals x squared, so I know they defined one function for me, and g of x equals -2. Graph the function e. So they're telling me to graph a different function that is created by adding f and g. It basically means I must add the y values for both the functions for the same x coordinate point. What do I mean by that? I think the easiest way that I would add two functions is by creating a table. It's beneficial, especially, personally to me it's beneficial when you have a table to look at before you plot anything on the graph. So one row in your table, just give that space for x itself. That spot is for x values. Okay. The second one row, I'm just gonna put the y values for first function, which is this f, right? The third table would be for g, and then the fourth table would be for the new function e. Now, as I'm looking here, I can see that when I can start putting points in. I have no idea what it is when it's at -3. Now, okay, when you take a question like this, they might not give you the function, which is a problem, right? They might just give you the graph itself and ask you to figure out what is this sum of two functions. So always, I'm just going to model this for you. I'm just going to look at this. I'm going to ignore this for now. Ignore the fact that I know what the equations are. Looking at this table graph itself, I can see that when x equals -2, y is +4. So can I not say x is -2, f is +4? Which makes sense if you look at the function. Let's just say you know the function, right? Plug in -2, -2 squared is +4, right? I see that g is a constant number, which is -2, right? So I'll just put -2 here, and I'm done, right? And I would just continue doing the same thing over the next few points. I would plug in -1, 0, 1, and 2. If I plug in -1, I'm looking at the graph again. I'm ignoring the fact that I know what the functions are. I'm plugging in -1. I'm looking at -1. I see the y value is +1. This is g is just a constant forever, right? So that doesn't even matter for me. G is just -2 forever. Now, I look at 0, it's 0. I look at 1, we're back to 1. And I look at 2, we're back to 4. Now, e is basically sum of these two numbers, f and g, right? So if I were to add 4 and -2, I would get 2. 1 and -2 is -1, 0 and -2 is -2, 1 and -2 is -1, and 2. 4 and -2 is 2. So now, when I'm plotting this new graph, I'm looking at -2 and 2. So the x value is -2, the y value, the new y value is +2, which is here. -2 and +2 is there. -1 and -1 is here, right? If you check it, the x value is -1, the y value is -1, 0 and -2 is here. Then you got 1 and -2, 1 and -1, which is here. I'm looking at this x value, and this are my y value, right? 2 and +2 is here. So graphing this, it might not be good, perfect, but I just want to get a clear idea of it. That's all I care for now, because my points are precise, right? So my graph looks something like that. That's my graph E. Now, write an equation for E. Let's pull in these two equations now. I know f is x squared, g of x is negative 2. So equation would then e equals f plus g, right? F is x squared and g is negative 2. So I'm basically just did x squared minus 2, right? And if you plug in points, you would confirm it that this y values are right. To find the x-intercepts, you basically have to set the equation equal to 0, because for the x-intercept, y is 0, right? So x squared minus 2 equals 0. Solve for x, I would add 2. X squared equals 2. X equals positive negative square root of 2, because you will square root it. So basically, this point right here is square root of 2, and this point right here is negative square root of 2. Those are the x-intercepts, right? Y-intercept, we can look at it, it's negative 2. Now, it's asking, after graphing E, see which statements below are true and explain, right? So is E an even function? I look at it, I can see, I mean, my graph isn't as perfect, but you can also look here, like, the values start to repeat once the x value reaches 0, right? They're back to negative 1 and 2. Negative 1, negative 1, 2, 2. That basically means it's reflected over the, what axis is this? Y-axis, right? So this is an even function. That's one way to say it. Is if you're given a graph, if it's reflected over the y-axis and it does nothing to the graph, that, or if it's symmetrical to on the y-axis, then it's an even function. So yes, it's an even function, and my first argument is that it is symmetrical over y-axis. My second argument that I can talk about is I know the equation as well. X squared minus 2, right? All the exponents are even, right? So this exponent is 2. Here, the exponent, there is no x, so it's basically 0, right? That's also even, right? So all exponents are even, making this an even function, right? So even function. It is true. Y-intercept for E is positive. It's not true because we found it's negative 2. So it's actually false. It's negative 2, right? E of x is greater than 0 when it's between the two x-intercepts. Meaning, when it's between the two x-intercepts, all of these values are greater than 0, which is false because the y values are less than 0. So I'm talking about this right here. They're saying that all the y values are greater than 0 between this two x values. That's what this is saying right here. It's a false statement because it's actually less than 0. If it was greater than 0, then it would be on this side of the graph, right? Not at the bottom. It would be above the x-axis. So it's false. It's false because it's e of x is less than 0 for those x values, right? Not greater than 0. And that's all. So all of these things are basically like observation skills and like knowledge that you need to figure out, like if it's symmetrical over the y-axis, point out where the y-intercept is, and like figure out if it's greater than 0 for a certain point. So that's your like observation skills and stuff. But yeah, the only like new skill for this one is like you being able to create the function e given f and g, and the information that they're both. E is basically the sum of those two. Everything here basically is like prior knowledge that we learned in this unit, or it's like observation things, things you can observe and then answer. Alrighty. Here, this is a different question because now instead of adding, they're asking you to subtract it, right? So this is where I would actually create a table again. Every single time, I would always suggest creating a table. It just gives you like a more detail about the points itself, like points. So first table for x, second table for e, for f, because that's f next, and then there's g, and then one for e. I would plug in points. I can plug in -2. Okay, I can plug in -2, -1, 0, 1, 2. I'm also gonna plug in 3, and I will tell you, I mean, it doesn't matter if you plug in 3 or not, you could stop at 2 as well, it doesn't matter, but I just want to go in detail and plug in 3 as well. Okay, plug in -2. I'm looking at the graph again, -2, comma 2, right? If you look at this, it's at 2. F is 2. G is -2. Y equals X basically means I'm just gonna copy the answers for G, copy the X values for G, but we'll still confirm it just by looking at the graph. -1 is here, and it's -1 for both. It's where they intersect as well. So actually, if you look at it, they could also ask you, where do F and G intersect? There are 2 points where they would intersect, right? Oh, that's a great thing. They could definitely ask you that, but that's unit 3 radicals. That's some not over there for the EOCs, right? Plug in 0, F is -2, G is 0, plug in 1, F is -1, G is 1, plug in 2, this is 2, this is also 2, plug in 3, you cannot see it, that's where this information can come and become handy. It's 7, actually it is, you can actually 3, see, 3 is 7, yeah, look at that. And then this is 3, and I would simply subtract the two values. 2 minus -2 is +4. -1 minus -1 is 0. -2, which is -2, -1 minus 1 is -2, 2 minus 2 is 0, and 7 minus 3 is 4. Okay, let's plot the points. -2 comma 4, -2 comma 4, -1 comma 0, so that's here. 0 comma -2 is here. 1 comma -2 is here. 2 comma 0 is here. 3 comma 4 is here. So I'm just gonna graph it and just like eyeball the graph, like create a random, not random, but like connect the points is what I'm gonna do. I know it's something like this, and it's going through these points right here. Yep. Now let's write the equation for E. So it's basically F minus G. F is x squared minus 2. G is just x, so it's x squared minus 2 minus x. Actually, to find the x-intercepts, just look at the graph, right? You actually have the x-intercepts. Your x-intercepts are -1 right there and +2, right? So those are the x-intercepts. You could also use diamond method here. I would suggest you use diamond method here because it's just good practice for you. But again, observation skills, right? You could just do that, right? And x-intercepts are -1 and it's a +2. Now continue. After graphing E, see which statements below are true and explain why they are true or false, right? E is an even function. Well, it is not. It is this is symmetrical, but it's not symmetrical over the y-axis. It has been shifted, right? No, I'm not saying it's shifted. I mean, it is shifted, right? I'm not saying that. I'm saying it's shifted, right? Oh my god. Yeah, it's shifted. So now the new axis symmetry is somewhere here. See, if that happens, it's not an even function. It must be symmetrical towards the y-axis for it to be an even function. So this is not an even function. It's actually a neither function, neither even nor odd. So it's false statement. And here's my two argument, right? Not symmetrical over the y-axis. The second reason I would say, just look at the equation itself, right? I have x squared minus 2 minus x. Your exponents are 2 0 and 1, right? They're even and odd in them, right? So it's neither, because you have mix of numbers. You can either have only odd or only even for it to be either odd or even. If you have a mix, you have neither. Now, y-intercept for E is equal to the y-intercept of F, which is true because, again, observe it, F is this right here. The y-intercept for F is -2, right? The y-intercept for E is also -2. It just go through, just can't see it, it's my bad, but it's the same, right? So the y-intercept is the same and it is a true statement. True. Now, for what value of x values, for domain, oh my god, I can't read, okay. For what domain of x values is e of x less than 0? That means I'm looking at the graph where it starts being on this side of the graph, of the axis. When I'm looking at it, the first point that it starts to happen is right here, and that is -1. It's not included because it's not saying greater than or equal to 0, so you cannot include -1. So I'm just going to say -1, comma, it's continuing being on this side until it stops here at 2. You could say between -1 comma 2, or you could also write it like this: -1 is less than x, which is then less than 2. So that would be the domain of x value. So if I were to plug in any values between -1 and 2 for this equation right here, I would always get a negative number. That's what it's saying. Always. That's what it's saying. Perfect. Question 3. The graph of log x is transformed to the graph of g of x as shown. Which transformation results in g of x? Well, a vertical compression by a factor of 1/2 and a shift left 2 units. Now, here's a problem. If it is shifted left, there is an asymptote here. If it's shifted left, wouldn't the graph move left too as well? Wouldn't it look like this, something like that? But it doesn't look like that, right? So it did not shift left, right? It didn't shift left, so I could eliminate just A. B is also saying it shifted left too, so I could eliminate that as well, right? That's what I'm thinking. Now, a vertical compression by a factor of 1/2 and a shift down 2, or a vertical stretch by a factor of 2 and a shift down 2. So that is something that I have to test myself. Now, I could do it in 2 different ways. I could just pick, there's only one way I would do it, technically. It's by picking a point, okay, to test. I'm gonna pick a point that is on the grid, okay. There are 2 points you can pick. I'm gonna pick, let's just say this one. This point is 10, 0 for my new graph, right? And, oh, this is even better, right? I'm looking for the value of a, right? So could you not just say y equals a log of x? It shifted down 2 because both of them are saying down 2, right? -2 outside, right? I'm gonna plug in 10 and solve for the value of a, right? So if I were to do that, I would get 0, y is 0 equals a log 10 minus 2. First step, add 2. 2 equals a log base 10. If there is no base, the base is 10. Remember that? 10. Log base 10 of 10, basically, if their bases are the same, it's like 1, right? Well, you could also test it, okay? This is the original graph. Log base 10, log base is right, it's already given to you, and if you check it out, the value when x is 10, it's 1. The y is 1, right? So 2 equals a. So it's actually stretched by a factor of 2. So it's D. C isn't that. Alrighty. they're asking me to graph g of x and f of x. I'm just gonna first graph g of x, 2 to the power of x. Plug in points, it's gonna help you. That's the best thing I would say, always plug in points. Plug in 0, starting with that. 2 to the power of 0 is 1, so first point is right there. Now plug in 1, 2 to the power of 1 is 2, next point is right there. 2 to the power of 2 is 4, so it's right there. 2 to the power of 3 is 8, which is outside of my grid, so I'm just gonna plug in those points. I remember, I'm just gonna also think about this as I'm doing this, remembering the fact that it's an exponential function. That means there is a asymptote right there. There's an asymptote here, right? And since there's an asymptote there, I know it gets closer and closer, but never touches it, and looks something like that. That's the original graph, g of x, right? To graph the new one, I'm just gonna have to start figuring it out, right? So first thing they want me to do is reflect over the y-axis, because there's a negative in with the x, right? So that's horizontal like thing, so it's a reflection over the y-axis, and it should look like, I'm just gonna draw a dotted line because that's not my final graph, right? But if I were to do that, let's just say this point is here, this point is here, this point is still here, and it will look something like that. That's a reflection over the y-axis. So this negative is taken care of, and now I'm going to shift it down too, right? So then my new asymptote is at -2. This is my new asymptote, right? Horizontal asymptote. I'm going to shift the graph down too, so then my new point here shifts down too. All of these points shift down too. So then they look like, so this is the graph for f of x. The one that I just drew is f of x. So I'm just going to label this f of x. This is g of x. Yep. Now find dominant range of g of x and f of x, right? I'm just going to do f of x first. F of x. Let's start with domain. So sorry, I meant g of x. I don't know why I said that. Let's just start with g of x, my original function. Yeah. See, exponential function has no limitations, so you could plug in all the numbers. This graph is gonna keep going left forever, right? So it's -infinity, comma, positive infinity. That's your domain. Your range, well, it's not gonna go down forever because there's an asymptote there. That means the asymptote is stopping it from crossing it, and here the asymptote is at 0. And since it's never gonna touch it, I cannot put that. I have to put a parenthesis there. It's gonna go up forever, right? After that, so it's 0, infinity, and that's the range for the original function. Now, f of x, the new function that I had created. Again, no limitations, right? It's gonna go left forever, and it's gonna go right forever as well. So you have -infinity, comma, positive infinity. Now the range got changed, right? Since it shifted down to my new asymptote is at -2. So now it goes from -2, infinity. That's the range for f of x, right? Now find the equation for asymptotes for g of x and f of x. So since it's an horizontal asymptote, it's gonna be y equals something. This is the first one, is that y equals 0, right? And now because it got shifted down to, my asymptote changes and it becomes y equals -2. State the end behavior for both f of x and g of x. So when you talk about end behavior, you want to talk about both the ends. I'm just going to start with the f of x. I'm just going to write it up right here. Interesting. Why do you say f of x first? So f of x is this new graph, right? Let's talk about that. Let's talk about the left end. As x goes to -infinity, meaning if I were to pick something and I go towards the left side, my graph is going to go up forever, right? So as x goes to negative infinity, y goes to positive infinity. Then as I talk about the left side, now I'm going to talk about the right side. As x goes to positive infinity, now here's a problem. I've seen people saying negative infinity, but the question is it ever going to cross negative 2? It's never going to cross it, right? So it's going to get closer and closer to it, but never touch it. So actually y approaches negative 2, not negative infinity. Now for g of x, as x approaches negative infinity, that means as you go towards the left forever, it approaches 0, right? Y approaches 0. And as x approaches infinity, y approaches infinity as well. And that's it. Those are the two end behavior for two different functions, right? Alrighty, moving on to the next one. Find the external solutions. You guys can do this. This is something that prior knowledge, right? This is new, right? Let's talk about this. Given f of x equals to the power of x, g of x is created by doing the following transformation, reflecting where the y-axis, shift, and stuff like that. Write an equation for g of x. Let's do that. Write an expression. So I know it's 2 to the power of x. Now, reflection over the y-axis means the x is negative, right? Vertical shift up 2 means there is a plus 2 on the outside somewhere. And then horizontal shift left 4 means there is positive 4, right? So over the y-axis there's a negative, shift up 2, vertical means outside, horizontal shift left 4, there's a plus 4 outside, I mean inside, up there with the x. Now to write g of x in terms of f of x, g of x equals f of x. Now I'm just going to talk about this again. Over the y-axis it means there's a negative, then shift up 2 means there's a plus 2 outside, and then plus 4 inside, and I'm done. That's it. Moving to the next one. Which of the following expressions could represent the graph below? Now looking at this, if you were to plug in 2, see which one gives you negative 3, right? This one doesn't give you negative 3, neither does this one. Now both of these are the same graph. They represent the same graph. So B and C are same. You could plug in points and check it. Let me help you plug in points. 2 minus 2 is 0. Cube root of 0 is 0. 0 minus 3 is negative 3, which makes sense. Negative 2 plus 2 is 0. 0 minus 3 is negative 3, which also makes sense. Plug in 3. 3 minus 2 is 1. Cube root of 1 is 1, negative 1 minus 3 is negative 4, and it would continue making sense, right? The reason why these two are the same is that they just took this negative and put it in there, right? And distributed that kind of thing. So they both are kind of the same thing. And you can plug in points. Actually, it also makes this an, if I were to draw it from here without transformation, it also makes an odd function as well. But this one is not an odd function, but its parent function is odd. Mr. Patel, that's me. Hit a baseball. What do you say, baseball ball? Oh, wow, interesting. Okay, whatever. Prove that his equation is wrong. So here's my equation. To prove it wrong, see, I've only considered the two x-intercepts. I haven't considered the height of it, right? So in order to prove me wrong, plug in 15, and when you were to plug in 15, you would get not 112.5, like this equation is saying. You would get, I think, 225, because 15 times 15 is 225, which does not equal 112.5, meaning my equation is wrong because I haven't considered the vertical scale factor. I only considered the horizontal landing and starting point. How do I consider the vertical scale factor then? Well, I simply use a variable a, let's just say that, and find the value of it by plugging in this point, 15 and 112.5. So 112.5 equals a times 15 times 15. That's 225. So A is 112.5 divided by 225, which is 1/2, I think. So so you could just say it's 1/2 x times 30 minus x, and you're done. Talking about reasonable domain and range. Domain, see, talk about this. Baseball, so the context of the problem, right? You have to be using logical here. If this represents time, I cannot go back below 0, right? So the lowest time I can get is 0. And I could include that, right? 0 seconds before I launch it. Now I launched it, or I hit it. There's a certain point where it's going to touch the ground. After that point, it doesn't matter because, yeah, it doesn't matter. And it's at 30 seconds. Or, sorry, 5 feet wide. It also represents, like, height as well. But, like, this represents time, right? But, like, 30. Distance, yeah. After this point, it doesn't make sense, right? The range, so I cannot go below the ground, right? So like it's gonna start at 0, and the highest it goes is 112.5, and that's your range. Perfect. Moving on to the next one. Given f of x equals x squared, I'm just gonna graph a rough graph for it, which just looks like this. You guys can be precise however you like. It's gonna save time because I'm already at 31 minutes. The first thing it does is it reflects over the x-axis, so it looks like this. Reflects over the x-axis first, and then it shifts down too, so it looks something like this. That's my graph. It's parabola, okay? It's not parabola. I mean, it's parabola, but I didn't graph it parabola. But you know, this is what your graph should look like. Does it have the same vertex? It does not have the same vertex. Does it have the same x-intercept? Nope. Same y-intercept? Nope. Same axis of symmetry? Yes, it does have the same axis of symmetry because I haven't shifted left or right yet. So the symmetry hasn't changed yet. So it is D. Now, this one, if you were to graph it, it will look something like this. Oh, that's not what I meant. You know what I meant, like a straight line. Okay? You guys can plug in points and figure it out, right? But that's the F, right? It shifted left too. Now, if you were to reflect it over that, it will look something like that. Now, these are the same vertex. Yes, it does have the same vertex because I haven't shifted up or down yet. So, the vertex hasn't changed yet. X-intercept is also the same. So, graphing it is the only thing that's going to help you figure these questions out. Graphing it and then looking at it. Y-intercepts are not the same. They're the same symmetry. Yes, they have the same axis symmetry. Alrighty, moving on to the next one. These ones are easy. If you must just test the point. All the exponents are odd, that means it's an odd function. This one is a bit tricky because if you were to graph it, it look like this. Plus 2 means it's shifted up 2, right? Now, this is symmetrical towards the y-axis, so it's actually an even function, right? This is not symmetrical towards the y and x, it's out of the origin. It doesn't even go through 0, so it's actually neither. This one is symmetrical towards, so if you were to reflect it over the y and x-axis, you would get the same graph. So this is an odd function. It also confirms by it goes through 0, 0. This is an even function. This is neither. Alrighty. There's a question at the bottom. You can figure out the domain and range by graphing it. You know, figure out the vertex point, y-intercept, and behavior. It's easy. You got this. And look at my answers if you need help. This one I'm really want to focus on because there's multiple things you could do here. I've seen people moving the graph up 3 first, then reflecting and stuff like that. I think I would always start by moving it right 2. So I'm just going to graph it here. If I move right 2, my graph looks like this. It's going to mess around here, so then I can figure out what is the location. Then I will reflect it over the x-axis, so it will look like that. And then shift it up 3, which is around here somewhere. So wherever my graph is looking like this is my answer, and it's right there. See, this one is way up there, so that's not even right. This one is down there. This one is actually in the opposite direction, so it's B. That's the end of the video. Hopefully that makes sense.